All right, we're back here at Automate Live. We're rolling through day 2. My name's Chris Lukey, host of the podcast Manufacturing Happy Hour. I'm joined all week long by Jake Hall, the manufacturing millennial, and we've got Eric Geyer from Advantech. Welcome, Eric. Good to have you here.
Thank you, Chris.
We'd love to get to know you a bit before we dive into smart manufacturing, before we dive into, I'll call them the props, but we know it's technology that we have here. We got a lot to cover, but how did you get into this industry? Give us some background on how you got to Advantech.
Sure, you bet. Well, it's a lot of layers to the onion, Chris. No, just kidding.
I don't doubt it. I don't doubt it. You look like a complex guy.
I've been at it for about 32 years. Probably shouldn't give that number, but I started in the chip side of things, right? So I was in a distributor called Wiley Laboratories. I started in Boston, but then went out to Seattle and Silicon Valley. I got called up to the majors and did Silicon Valley for about 5 or 6 years, being an application engineer for a lot of different lines like TI and whatnot. So I was always into the DSP part, which lends itself well into the industrial automation space. Then I did a rep firm for about 20 years, went back into distribution, and then been at Advantech for a year. But in my various roles with analog devices and Xilinx, I spent a lot of time in the robotics and machine automation area. I'm from Boston. I covered New England largely, but right now it's more of the eastern half of the U.S. for AI and automation customers, OEMs typically, rather than selling right to a Ford or something. It'd be someone in the middle like a Locus or Symbotic that would then go to DHL or Walmart and build out their warehouses. But and then at Advantech, I was supporting them at Avnet as their distributor, and I got pulled in to be a direct salesperson for them, covering all those different robotics and automation customers.
Awesome. So Advantech's tagline is enabling an intelligent planet. And when I was kind of doing some research on you guys are everywhere. It seems like you're almost in every single industry that's out there bringing solutions. But let's talk kind of specifically around manufacturing. So how is Advantech as a whole, give a summary of Advantech, but then really how are you impacting smart manufacturing and moving our industry forward when it comes to digital transformation and IoT solutions?
Sure. Yeah, so Advantech is about a $2.3 billion company, so we have a reasonable scale and like that. We're 40 years, this is our 40th anniversary. Ooh. So we've basically started with industrial PCs. The founders who are still with the company wanted an industrial PC, couldn't find one, they built the company on that, so that's our premise. We have 41% market share in that space. So that fuels, our 2,000 or so off-the-shelf products fuels all this innovation, and then we usually craft that to modified designs, whether it's modified or full custom, to meet people's needs. So typically it's x86-based products with HMI, what have you, and then now it's NVIDIA, right, largely. So where we get into this industrial automation and IoT, it's really helping people with taxes they have to pay, both from a security standpoint and more importantly, functional safety. These engineers that are geniuses that make all these things work out here, there's certain things they have to do to get SIL 2, SIL 3 rating, these terms. If something's programmable, there's a 61508 protocol that says, well, is it doing what it's supposed to be doing? And so you go to the TUV Rhineland, who's over here in one of these booths, and the German folks tell you, yes, you pass, or no, you don't. And so we try to give them the architecture, the white papers to say, okay, here's how to craft your design. You can't just Band-Aid it into a system.
This is
it
the
has
blueprint.
to be there architecturally. You're looking at all these sensors, right? So it's trying to give these bots eyeballs for depth sensing, depth perception, certainly LiDAR to give this 3D or two-dimensional image of it. The depth sensing gives it a 3D image of it, so it can differentiate between the microphone and what's behind it, that kind of thing. Kinetic MEMS and all kinds of things to try to give but it needs to take that sensor fusion and allow decisions to be made, right? So depending on how complex you want to get, you have to vote 1 out of 2 or 2 out of 3, and now you agree. Say like a simple case would be the kinetic MEMS, where you have rebar in there and it throws off the compass, but the accelerometer says, no, we're not moving, or we are moving. So you get people agreeing on what's happening. So again, leading towards functional safety. So that's one aspect of it. The other is predictive maintenance, right? So it comes down to CapEx and OpEx. You know, people are buying $500, $1,000, $2,000 boxes to do these things.
Yeah.
There better be a return for that investment. Well, it typically is you're reducing truck rolls, or you're seeing and fixing problems before there's blue smoke. So you're staying online longer, right?
Yeah.
Or you're increasing your throughput. You know, we have so many products that manage, it's quality control. It's both making sure you're managing defects and seeing that, but you're also increasing the throughput. And there's so many different ways that my customer base is attacking the problem, whether it's warehouse automation or a factory line. And NVIDIA and Intel, they come up with some great chips, but we bring that all together with a rugged platform that will be there for 10 years. Part of what we bring that is life cycle management, which is not an easy thing to do. It seems easy, but these CPUs are typically only meant to be around for a little bit, and now they're extending their lifetime a little longer, and we play a lot of games with our huge supply chain grouping to keep things alive for a long time. And now you have them for 10 years rather than 2 or 3 or 4 and have to requalify them. So that life cycle is key for these people, because they don't want to have to redesign it every year, especially when you're getting certifications. You want to run that out, have your product have a long life cycle, yet at the same time be at the tip of the spear, whether it's Intel at Raptor Lake or NVIDIA, which is the Jetson Orin, is their latest and greatest product that we work with. So it gets you on the front end and then keep it around for a long time.
So I want to go back to basics real fast, like talking smart manufacturing, Industry 4.0. You gave a pretty good overview of all the things that you do, but on a down-to-earth basic level, what's the main challenge you're seeing manufacturers face around smart manufacturing, around Industry 4.0, the things that really allow you to bring your solutions to life and bring their operations to life? How do those conversations usually start?
Well, a lot of times there's obviously intelligence in these systems, and that's great, but it's adding more and more, right? So the algorithms required for the AI at the edge is growing, right? Mm-hmm. So the data sets are growing, and so what happens is you have these decision trees that whether we craft them, these pre-trained models that we build or NVIDIA builds, or they're beautiful 300 company ISV, independent software vendor network that works, say, on NVIDIA Metropolis, right? Yeah. That's their umbrella that basically understands how to utilize space and manage whether it's a city or a warehouse. So all these ISVs that are looking at object detection, image classification, and these kinds of algorithms are growing more and more complex, more and more sensor data points. Like just the visual sensor that's looking at out to make these decisions, it was, a USB camera, a MIPI camera, then it's a gigabit Ethernet camera, and now the data rates are getting so big, now you're looking at GMSL2 type interfaces, like from Intel's RealSense cameras, and now they need that 3 gig or 6 gig type speeds to keep up with it. So the challenge is how do we manage all this data point, this cloud of information? How do we work this into, again, trying to improve our CapEx and OpEx? But it's both with pre-trained models that are throughout our whole ecosystem, could be consultants, but it's a matter of having the high enough performance solution, but also this no-code type lift, because these companies don't have 1 million PhDs. Some do, but some of these startups, 10, 20, 30 people, extremely bright, but they need time to market, right? They need to address what's the difference between them and the next company, and a lot of it is this AI at the edge capability, and then how do they manage it back with bridging OT and IT, right? It's one thing to have the sensors do what they want to do, but now you have the back end, in terms of, say, communicating that back to their cloud. And at Advantech, we're a Microsoft partner. I mean, we deal with AWS as well, but we deal with Azure and whatnot. So now you're having these digital twins, and so, okay, what do we do with this? And it's like, you can see that Jake here is starting to act a little wonky. Yeah. So we're going to have to, check on him before he passes out entirely.
Jake starts acting wonky at the end of
Yeah,
our interviews
absolutely.
every day. So
And we'll
good
save
example.
money because you don't want him offline. You want him on that mic 24/7 going. So that digital twin manages it.
I love the conversation that you brought up on working with like startup companies, right? You're working with the massive companies, but you're also working with ones
Yeah.
that are just starting out. I guess, what coaching advice would you give to companies who start to want to leverage this technology? What are the conversations at the ground floor that they should be having with you when they want to start bringing this technology into their solutions?
Let's see. So I think, I mean, they understand the problem. They know they need to have this generic term AI at the edge, right? So in order to manage give their product cycle longevity, right? You need something that has enough, trillion operations per second to manage what you need to do.
Yeah.
Like these NVIDIA products start at like 10 trillion operations per second and now go to 275. That's just on these Jetson products, not to mention the stuff that does ChatGPT. But you need to have the capacity to grow within that. But you have to have an architecture that allows you to get there, right? Like I said, you can't band-aid it into your solution. You have to start from ground zero. So when I'm in there, I'd love to have a whiteboard that's just blank. And now let's discuss what's going on and how to build up this, and both from a usability visualization standpoint, really connecting both sides of it and looking at the use cases. For me, I have to go and say, hey, have you thought about SIL 2 or SIL 3 rating? And some of these little bots, it's not gonna hurt anyone. It's only 60 pounds. Well, but you have another one that's 120. Now that could do some damage. Symbotic has an AMR that goes 25 miles an hour. So they want to know no one's down in that part of underneath the Walmart facility when they're cleaning up the spilled pineapples that spill over during the day. We have to make sure this is clean. So the advice is, to really craft that room for that functional safety in front, because it's going to be a tax they're going to have to pay eventually. So, don't just have a compute platform. Really have enough room and have the sensors and have the GPU capacity to run it. You can do a lot of things on x86 or in ARM processors, but you need kind of an Orin GPU to give you that room to grow with the future.
So we got 2 minutes left. What's your 2-minute answer to this last question? What is your prediction for the automation space, your space, etc., over the next 1 to 2 years? And feel free to tie in the hardware that you brought to this answer as well.
Yeah, well, no, it definitely in the next couple of years it's going to be a tsunami of different companies. I mean, you see it here. It's so exciting to see what these people are working on. All the robotic arms. It's motion planning of these. It's safety around that, making sure the cobots are all interacting. It's connecting with this data lake of information and all these digital twins to make it more seamless. And people are going to realize that as they invest at the edge and put more intelligence there, they're going to have a lot of opportunity to recover that money by reducing truck rolls, staying online longer, increasing throughput. In the end, it's all about the CapEx and OpEx, and you're going to see this incredible wave of Metropolis, or on the Intel side, One API users that are taking advantage of the GPU concept. And because of Moore's Law, you don't really have the opportunity to just keep doubling your performance every year. You need that parallelism, right? So you need a Cortex A73, 78, and an increasing capability of the GPUs. Like I said, 275 trillion operations per second.
Yeah.
You can get up those fast with these genius ISVs that are creating algorithms that need pruning and quantization to just keep up the latencies that demand real-time functionality.
The demand coming from these systems now that are requiring, the new innovation really puts a lot of stress on the hardware. And I think that's one of those things is, in order for this industry to expand, you guys have to keep pushing what the hardware can do to support a lot of these products.
But you don't want to necessarily so that you have to do Verilog code and build this up. It's like doing assembly language. You need this kind of no-code environment where people can just pull this a la carte menu of edge AI suites that you have, all these pre-trained models, and do little changes to it to get to market fast. And that'll be key, this huge ecosystem of both software and hardware, and marrying that together. Because basically this is an iPhone, right? The NVIDIA solution, the Intel solution, it's now those 300 ISVs are all the apps that you have in your iPhone. It's kind of a blank canvas for you to operate with.
Well, Eric, we appreciate you taking the time to jump on the show today. For all of you out there, we're going to be back with more Automate Live interviews coming right up. Thanks for tuning in.